Example 4.3. Two books on a table. Consider two books at rest. What is the magnitude of the force that the table exerts on the lower book? So here you have two books. I will label them as book 1 and 2 and let their masses be M1 for book 1 and M2 for book 2. We need to find the magnitude of force that the table exerts on the lower book. So we basically need to find the force table exerts on book 2. So let us first show all the forces acting on the books. We will start with book 1. First you have the force due to gravity Fg. I will call this Fg1 for book 1. And then we have the normal force that book 2 exerts on book 1. I will call this N1 as book 2 is supporting the weight of book 1. And if I choose the vertical to be my y-axis, I can write equation of net force for book 1 as F net y to be equal to 0 because the books are at rest. F net y is the vector sum of all forces acting along y-axis. We have two forces here, N1 and Fg1. And when we take the vector sum, we have to take the direction into consideration. Upward direction, we will take positive. Downward, we will take negative. So we write N1 minus Fg1 equals 0. Or you can write magnitude of normal force on book 1 is equal to the weight of book 1. And if we want to rewrite this in vector format, you can write that N1 bar equals negative Fg1 bar. This means that the normal force on book 1 is equal in magnitude to the force due to gravity acting on it or its weight, but is in opposite direction, as you can see from the figure. Let me call this equation 1. Then we do the same thing for book 2. Now we will find all the forces acting on book 2. So let me call this 1 and 2. The first force we have will be the force due to gravity, which we will call as Fg2. And then we will have the normal force that the table exert on book 2. I will call this as N2. Now since book 2 was supporting the weight of book 1, it exerted a normal force on 1. From Newton's third law, book 1 will exert an equal and opposite force on book 2. So there is a force on book 2 because of 1, which I will call as F1 on 2. And this force is equal in magnitude but opposite to the normal force which book 2 exerts on book 1. So I can write for F12 as F12 to be equal to negative of the normal force on book 1. Normal force on book 1 is negative of Fg1. So we write this as negative Fg1. So that tells me force exerted by book 1 on 2 is equal to Fg1, which is nothing but its own weight, which makes it obvious as book 1 is on top of book 2. So book 2 will feel its weight. So therefore, the forces acting on book 2 are Fg2, force due to gravity acting on it, the normal force, the force exerted by table on it, and the weight of book 1, which is F12, that is equal to Fg1. We want to find the force the table exerts on book 2. So we are basically looking to find what is N2. So we will apply equation of net force if we choose the vertical as y. So I can write F net y for 2 to be equal to 0 as the books are at rest. So we can rewrite this as F net y is the vector sum of all forces along y-axis. And when we do vector sum, we take direction into consideration. Upward force we will take positive, downward force we will take negative. So I can write this as N2 minus F12 minus Fg2 equals 0. So that will give me the normal N2 equals F12 plus Fg2. And we know that F12 is equal to Fg1. So I can write magnitude of the force table exerts on book 2 to be equal to Fg1 plus Fg2, which is nothing but the weight of the two books, which we can write as M1G plus M2G, or that will be equal to G M1 plus M2. So this is the magnitude of force. And if you were to write this in vector format, you can write this as N2 bar equals negative of F1G bar plus F2G bar, which only means that force exerted by table on book 2 is equal in magnitude but opposite in direction to the weight of the two books, as you can see from the figure.